Everyone. Thank you for attending the third part of HU LATAM webinar series. In these sessions, we plan to introduce Harrisburg University, its available resources, and the importance of data analytics as the first major that is coming to Panama. My name is Ruzbeh Sedigian. I am an associate professor of data analytics at Harrisburg University, and I have the honor to be the host of these weekly sessions. Harrisburg University is a private STEM-focused university in Harrisburg, Pennsylvania, with an additional location in Philadelphia, and soon we are proud to have our new location in City of Knowledge in Panama. HU has more than 50 programs in undergrad, grad, and PhD levels. We have 7,000 students who represent around 102 countries. Initially, H2 LATAM, or that's the way that we call it, Harrisburg University at Latin America, will offer a Master of Science and PhD in Data Analytics, which will be delivered in hybrid format, which is a combination of online and campus classes. But for now, due to the COVID situation, everything is going to be completely online. The HU Panama location will also offer cutting-edge professional development seminars and courses for the first cohort. We're going to have, in first and second cohort, we're going to have some scholarships too. If you have missed our past sessions, they are all recorded and you can watch them on our Harrisburg University YouTube channel. Without any further talk, let's start with our first fantastic presenter, Albert Sarvis. He is an assistant professor of geospatial technology and project management at Harrisburg University of Science and Technology. Mr. Sarvis has 20 years of geographic information systems, GIS industry experience, and more than 12 years as a GIS IT project management. His educational background focused on environmental studies, geographic, geospatial technology, and project management. Following a 20 years career as a GIS consultant, Mr. Sarvis joined Harrisburg University in 2011 as a full-time assistant professor of geospatial technology. He is responsible for coordinating teaching and aligning corporate faculty members for the program. He is the director of Center for Applied Environmental and Geospatial Technology and has been an FAA certified remote pilot since 2017. Please, Mr. Albert Sarvis.
Thank you, Rusba. I appreciate the introduction. That's a lot. I guess it just means I'm old, I suppose. I'm going to talk to you very briefly about what geospatial technology is at Harrisburg University, and then also a little bit about how we specifically use geospatial technology to do spatial analysis. So as I go through the slides, think of any questions you might have. There is not much Spanish beyond this title page, so I just wanted to put that out there. I'll talk about what geospatial technology is, ways that we apply it for spatial analysis, and give you a few examples of projects that we've done so you get an idea of the kind of work that Harrisburg University students have done. So I always like to show this photograph. It's of our Harrisburg University in downtown Harrisburg, Pennsylvania. But the reason I show it is to prove the point that nearly everything that we can track, or any piece of information or physical feature on the surface of the Earth, can be mapped. And because it can be mapped, it's got a spatial location. Spatial analytics comes into play. And so all of these different elements, just in this one small section of downtown Harrisburg, have pieces of information that we can track in a spatial way and model and analyze spatially. Geospatial technology, as we define it at Harrisburg University, are the three main technologies of global positioning systems, remote sensing, and geographic information systems. The key, of course, though, for data analytics is that 80 or more % of all information or all data has a spatial component, which really drives home that importance of having spatial analysis involved in any sort of analytics that you might run. Global positioning systems, very quickly, precise measurements for mapping using survey grade GPS all the way down to handheld units to collect information about locations on the surface of the Earth, which of course we then analyze. Remote sensing being the second primary technology of geospatial technology, being able to capture images of the Earth remotely so that we can build maps out of them. So everything from drone point clouds that you see in the screen here, to the 3D renderings of those images that we create from drones or other airborne platforms. Looking at remote locations for archaeology, and even looking at satellite imagery. This is Harrisburg, the Harrisburg area in Pennsylvania, with thermal imagery from one of the Landsat satellites about 7 or 8 years ago, clearly showing warmer areas around the city. This was taken in an August timeframe. And we can analyze all this information using geographic information systems. This is just another example of a three-dimensional model spatial model built out of drone imagery that was created using the technology that we teach at Harrisburg University. So lastly, geographic information systems, which is really where we do most of our spatial analysis work, whether it's command line in some sort of statistical package or the off-the-shelf geographic information system software, where we bring in all that spatial information. Again, this is Harrisburg looking at LIDAR data, which is elevation points, indicating higher and lower buildings along the river. We can take that information and create three-dimensional models out of that spatial data. So this is the same area of Harrisburg again, extruding those building footprints out to give us a three-dimensional representation. Of course, categorizing areas of the city based on zoning or land use types is another element of how we can put all this together in geographic information systems. And really the point for spatial analytics about geographic information systems is that ability to run analysis on the data that we collect. And so I wanted to take some time, most of my time here this evening, to talk about some examples of how we use geographic information systems or spatial analytics software to analyze spatial data. So the broad categories, right? Broad categories of spatial analysis. At the very basic level, it's understanding where, simply what is the location of different features, comparing them. Are there changes over time? So as an example, I like to look at the city of Harrisburg and some census data or population data that was collected over 4 decades. First, we have the city of Harrisburg and the individuals that lived there in 1900, excuse me. In that year was one of the first censuses done here in the United States where we actually had detailed information about every single person living in the city. So this is a current map with the historic location of individuals depicted. This is 1900. By 1910, we can see that pattern changes, so understanding where the city and the people in the city were. By 1920, expanded even further, and by 1930, the same footprint but much denser and more people. So we can actually analyze trends over time using this spatial data. And we've done a lot of work with this particular data set, looking at the history of the people that lived in Harrisburg in the early half of the 20th century. Another type of spatial analysis, one that is far more common than just simply plotting the location of something, is measuring things, measuring the size of a distribution, the shape of a distribution. Could be individual features or collections of features that have been distributed across the surface of the Earth. In the left-hand image, we've got 2 different population groups, Hispanic and African American in the Chicago area, Chicago, Illinois. And we can see how those shifted, and the mean center of the population is dramatically different between those 2 ethnic groups or racial groups. On the right side is the distribution of Harrisburg University students in the early years when the university first started, blue being the earliest year, green expanding, and red the most recent, but I think this is 2008, so it's quite some time ago. But it showed our expansion across the eastern part of the United States. In Harrisburg, with that same census data, what you're looking at here are the dots are the mean center of the population. Red to orange to yellow are the entire population in 1900, 10, 20, and 30. And you can see that the population is moving. The deviational ellipses, the colored circles or ovals, are indicating the extent of that distribution. But the point here is the red to orange to yellow dots represent the mean center from 1900, 10, 20, and 30, and they moved in a consistent direction. The African American mean center of population, however, started in the same location, same trends, but made a dramatic turn to the left, as indicated here, between 1920 and 1930. And historians want to know why that is. And so this was an interesting way of using spatial data to sort of unlock that mystery. Here, likewise, the Jewish population that had immigrated into Harrisburg from Russia is shown in green, and they followed a completely different trajectory over those 4 decades. So it's very interesting to see how this population, just in the small city of Harrisburg, has shifted over time, and different people, different groups of people are shifting in different ways, which is really quite fascinating. Another way that we can run spatial analysis is looking at how places are related to one another, whether it's proximity, this nearness, whether they're coincident, meaning they're on top of each other, very close to each other, overlaps over time, how things move around. One of the things that we're looking at here in this image, in the lower left, is a location of crimes across the city of Harrisburg. Larger circles indicate more crime, smaller circles less. But maybe we want to compare that to something like property value in the upper right map. That one has the more expensive properties are darker blue. And in reality, there really isn't much of a correlation, but there is a theory, of course, that less expensive property might be indicative of more crime, and in this particular case, it was not. Looking at distribution, this is that city of Harrisburg distribution again, but now we're looking at more of a cluster analysis. We've overlaid hexagons over the city and done a count of the number of individuals living within each of those areas. And this is a way of really looking at that city population and understanding it a bit more thoroughly. Rather than looking at individual points, we're now looking at density across the city. And so that density from 1900, 20, 30, 1910, 20, 30 has changed over time. Rather dense and compact in 1900, 1910, spreading out, but some of those dense areas remain all the way until 1930. So it was interesting to do that analysis, and now we can actually see things like density as opposed to just location. Another type, finding best locations and paths. How do we get from one place to the other? The images you see here on the screen have to do with emergency planning and allocating resources, determining detours around locations of, in this particular case, was a simulated chemical spill. So we want to find locations that meet a criteria. We want to find paths for evacuation that are safe. What's the best route? What's the best location to place things? The next example I give you is a very practical one that we did as a test for a local medical company. So here in the state of Pennsylvania, which you can make out, we have green dots that represent where healthcare providers were located. The larger circles are indicative of hospitals or medical parks where numerous doctors exist, as opposed to the smaller circles, which might be a single doctor or clinic across the state. Now, what we do with this is we wanted to help that healthcare provider understand how far away their members who might use their services are going to travel. And so what we've overlaid here is a 30-minute drive time. This is how far you can drive and still get to those individual green dots within 30 minutes. And so this shows that they have a pretty good coverage across the state of Pennsylvania, but with a big notable exception across the north central part of the state, big open areas where there are no healthcare providers within 30 minutes. Coincidentally, of course, there are very few people that live in that area of Pennsylvania. But let's say we have a new healthcare provider that would like to start at that location that you see on the screen, location A. Well, let's zoom in on that, and then we can see all of the existing providers and their 30-minute drive times, and clearly this new provider's not within 30 minutes of other ones. So it might be a good idea to do that. So we're going to run the analysis of 30 miles, or 30 minutes, excuse me, how many people are within 30 minutes. And if you look closely, I'll zoom in once more, you can see that there are individuals in red dots here, people that were not within the existing 30-minute drive times. And so this new location is a good location because we're now capturing healthcare members who might need to seek out that particular provider. So this is a practical example done for healthcare that shows how spatial analytics and just simply mapping drive times and locations of individuals can be very helpful. The last one is detecting quantities and patterns. That same information for the city of Harrisburg. In this particular case, if you remember, we depicted the African Americans in Harrisburg in blue. What you're seeing now on the screen is a cluster analysis that shows where the densest areas of that particular population were. Well, an interesting phenomenon happened in Harrisburg between 1910 and 1920 that basically relocated everybody in that lower right corner. So from 1910 to 1920, that population shifted. And so they had to leave the population cluster in that bottom right and expand out. And you can see in most cases, in many cases, they went to existing locations where African Americans were already living, and those became denser. If you look at the top center of the map, you can see how that grew. So this gives us a very clear picture of small, localized migration over time of individuals, specifically in Harrisburg. But hopefully you can expand that to think of other types of data where this type of cluster analysis would help. So looking for hotspots, classifying patterns, what patterns look like over time, especially looking at trends to make future predictions, which is, of course, the last. Here's the another group of people who grew in size dramatically between those two time periods. The last type of spatial analysis I want to talk about down here are the African American population over all 4 decades out across the city. The last type of spatial analysis is making predictions, understanding what the trends are, predicting interactions between features, and understanding where something might be occurring in the future. The imagery you see here are elevation models created from drone flights of a particular area in central Pennsylvania. And in the top right, we notice that there is a lower area the darker green. High elevation is yellow, red, and lowest is green. And we can pick out where a sinkhole or a depression in the ground was forming, and we can potentially see where other ones are, or do this same sort of overflight with a drone year on year to see if anything changes that we might predict where another sinkhole would open up in the area. So spatial analysis is used for lots and lots of different things. So I wanted to give you those examples. Now, also, just to talk a little bit more about the type of research that we do at Harrisburg University, this particular one was done using thermal imagery from a drone on Grand Cayman to analyze the invasive green iguana that they have a problem with there. We presented this a few years back, but this is an example of the remote sensing type of research that we do at the university. And part of this is run through our Center for Applied Environmental and Geospatial Technology. So in the Cayman Islands, they had an issue with a very rapidly rising population of the invasive green iguanas. These green iguanas were seen everywhere, and they had a real problem with them taking over, destroying trees, bothering their tourists, all sorts of things. And you can see the annual population from 2014 to 2018 nearly quadrupled, based on more than quadrupled, 1.3 million of these green iguanas on the small island of Grand Cayman. So they needed a way to get rid of them and identify where they were. And the problem is, from the air, they're very difficult to identify. So in that red circle is a green iguana. What we came in was with thermal imagery, and we did some testing to find out at what point during the day do those iguanas heat up so that they're visible with a thermal camera. At about 50 meters altitude, we're flying a thermal camera mounted on our drone, and you can see that across from 6 o'clock in the morning till 9 a.m., those green iguanas start to show up because they're heating up in that morning sun. We worked on the methodology to determine the best way of detecting these particular iguanas. So there are a lot of considerations, airspace, environmental considerations, the temperature, humidity, cloud cover, all these things we looked at, and they all affect the ability to capture high quality aerial imagery, especially difficult for thermal imagery where we have lots of different variations that can affect it. So we had to go through all of the permissions to get permission to fly there in 2 different locations on Grand Cayman. The resulting work was using a Matrice 210 camera or drone with the Zenmuse XT thermal camera and a Zenmuse Z30 zoom camera that we could zoom in on and determine whether we saw what we saw was actually an iguana or not. So these are the technical specifications that we worked with, using near-infrared or thermal infrared radiation, capturing that with that particular camera, and understanding the way that these animals would react to it. So using that thermal imagery, we actually created a map using the drone with a normal camera, taking numerous photos and stitching them together so you can see the resulting orthophoto on the left, bottom left, and then processing that data afterwards to determine what we're actually seeing and being able to overlay the location of those thermal images. And the final analysis is done in thermal imaging software, FLIR tools we used, and brought all of this information back into GIS ultimately to be able to map the locations. So I think I wanted to keep myself to about 20 minutes in case there are questions. I've listed the types of spatial analytics there on the right. And I think, yeah, there's just an image to pop in there. So I think I would, Rusba, if that's good, I will end here and see if we have any questions.
Thank you. That was very interesting. Thanks. Is there any questions? If there's any questions, you can type in the chat box, or I can connect your microphone if you are more comfortable to talk. But if you have any questions, feel free to share it with us.
I'm going to stop sharing my presentation so I can see if any questions come in.
Okay. I just had a quick question. I've heard that you have a geospatial analytics course too, so that the students who are joining data analytics probably are interested to take that course. Could you talk a little bit about that course too?
Thank you. Yeah, thanks for the reminder, because I completely forgot to mention it. So because we have the undergraduate geospatial technology program, we've developed numerous courses, including a part one of a remote pilot certification, a drone pilot class that just got developed. Because we have that entire undergraduate program, we thought it would be very useful to start to approach spatial analytics within our graduate analytics program. So back in early summer, our curriculum committee at the university approved a spatial analytics course that can now be offered as an elective within the analytics master's program. So I'm very proud of that, and I'm very excited to start teaching it hopefully as early as the spring.
Thank you. That should be a great course. Thank you. So I don't see any questions coming, so let's move to our next wonderful speaker, Dr. Kevin Parcell, who is an associate professor of data science and the academic program lead for graduate analytics at Harrisburg University of Science and Technology. Dr. Parcell has earned a Master of Science and PhD in the natural science and has conducted postdoctoral fellowships in the environmental and conservation science group at North Dakota State University and within the Nicholas School of the Environment at Duke University. Dr. Parcell manages a research program focused on the identification, prediction, and mitigation of disturbance in complex systems. His research involves a wide array of computational and statistical approaches, including data mining and informatics, machine and statistical learning, and forecast modeling. Dr. Parcell is program lead of data analytics, and I'm so glad to have him here today. Oh, he's also the chief scientist at WildFig, a data science and analytics consultancy with offices in Harrisburg, Philadelphia, and Chicago. So thank you, please, and please start your presentation, Dr. Parcell.
Thanks, Rusba. 1 second. I'm having technical difficulties on the talk. I apologize. We had this all worked out, and now it's not working.
No problem. It happens. So if you have any questions, audience, feel free to type your questions while. Okay, I think it's okay.
No problem. You should be able to see this now.
Yep, we can see it.
Great. Well, thank you everyone for joining. Apologies for that technical difficulty. Thanks for the introduction. Welcome everybody. I'm very excited to be able to talk a little bit about the analytics program, as Dr. Stegian mentioned, and a little bit about what we do and some of the experiential elements of the program and how we also get to collaborate with the community, which is something that I know as as the program and as the university expands into Latin America, we're really poised and interested in not just, teaching, but also, building those collaborations and sort of having that positive impact through collaboration with folks in other regions. So hopefully this will be informative. So a little bit about me. I know Ruzba just did a quick bio for me, but I think it's also important just to know a little bit about the vantage point of not just me, but I'm a very typical member of our faculty, and we're unique, amongst higher education institutions, both in the United States and I think around the world, in that we have lots of a myriad of very diverse and different experiences, and so I think a little bit of not just promoting myself, but a little bit talking about why we're different. So, I wear a number of different hats, as Ruzba said, while I'm the program lead and a faculty member at Harrisburg University. So I kind of check the academic box. I'm also an administrator. I also have an active research program. And so I'm a scientist, most likely not in that order. I normally wouldn't describe it in that order. But on the other side of my life, I'm also an entrepreneur. I run a data science consultancy, and so I have the real benefit of coming to the challenge and the opportunity of training students, not just from an academic standpoint, not just from a research standpoint, but also from the point of experience on the ground in industry, seeing how things go on a day-to-day basis. And many of our faculty have that kind of collaborative nature. Not all of them are in private industry. Some of them are doing public work and research collaborations with governments or NGOs, but all of them have that other piece outside of just the teaching, and that really brings a lot to our students, and our hope is that it'll bring that same level of experience and perspective to the folks that get involved here in HU Latin America. So just a piece of that. So one of the big questions that I think we often talk about as we talk about our program, and not I as the leader, of the program do this a lot, but all of our faculty have a big part in sort of talking about and why we're unique. And one of the big things, this is a clip out of a book, or a description of a book by James Gray called The Fourth Paradigm, and I think it really helps to open up the idea of how we think about the challenge of data science and data analytics and what our program is built to do. Okay, a lot of programs, a lot of research or training programs, university programs that attack lots of different topics, but specifically data analytics, tend to focus on things like either very specific topical areas, think healthcare or business, or they focus almost even more narrowly on a technology, a certain type of tool or a certain type of technology. And both those things in this new sort of emerging world of data that's both developing and growing as we work here are changing. And because of that, because the nature of while you might go to school start school, next month and pursue a degree in analytics, the reality is over the arc of your career, the world of analytics, the technology, the tools, the places it's applied are going to change dramatically. And we want to prepare students for that eventuality and not just for some, one moment in time. And so that's the sort of lens we take. Talking a little bit more directly about what is data science and data analytics. If you don't recognize this, if you're sort of new to thinking about this challenge, it's important as you build a training program, as you build an educational program to train students, especially to do a job that's so new and so young. What is it, and what should it be, and where will it be, and what will it be over time? Because our job is not just to train you for today, but to train you to excel over time and throughout your career. So one of the first iterations of defining data science that became wildly popular is this Venn diagram by a gentleman named Drew Conway. And this is about 10 years old now. And this was sort of the working thought process about what data science or data analytics was. And it was a combination of math and statistics. Specific expertise in a given area was a big part of that. And then what they called hacking skills at the time, and has really evolved to have a slightly different interpretation. This is the interpretation I use, and I don't want to speak for all of my faculty, but I think a lot of us share this viewpoint that our field is now really made up of a combination of still that math and statistics training that's fundamental to asking quantitative and computational questions, no doubt. The hacking skills that Drew Conway talked about is more formal now, because we really formalize it in the idea of, when he used the terminology hacking skills, he was thinking someone that was comfortable with a computer, someone that's comfortable about getting the data and hacking away at it in a point so they could get to what they needed and manipulate it. And those tools are really taught more formally in higher education through computer science. And while we don't teach students to be computer scientists, we do teach them to be very computationally literate and comfortable in a computational environment, and not just a specific environment today, but any as environments change. The final element, and I think the biggest difference between the very popular idea of what, you know, data analytics and data science is, and sort of the one that we embody at Harrisburg University, is our fundamental belief that the scientific method and scientific thinking, logical reasoning, they're critical. And the reason is because we replace, you know, the scientific method with what Conway called, you know, domain expertise, or, you know, and the reality is we see our students as folks that are working in a field as analysts, and most likely will not have one job in one domain throughout their career. And we believe any analyst that excels and has these tools can go and make an important impact in any field. And so we shape our Venn diagram a little bit differently, and we couch the whole thing in the broader perspective of any domain you go in, a data scientist can be impactful if they have a good command of these fundamental tools. So if you look at the university, our university's website, and our established program in the United States, this program is going to translate to Latin America. And so our mission is equally relevant in both regions. And a key element of our mission is to make you informed, effective, and influential. And oftentimes I take some time to talk to our new and incoming students about what that means. Okay. When we say that, you know, the vision that I and the faculty have is about closing the gap between where a student is at graduation and where they're truly become impactful in the workplace. And that's not just a mission of the analytics program, it's a mission of HU as a whole. It's one of the reasons why the university was built, and built in the way that it is. You know, in a lot of things, you know, that influences a lot of things. But most importantly, the idea that we have very experiential learning, hybrid learning, you don't have to walk away from your career. So all these things are the reasons why HE was built. But one of them is to close that gap. So many students graduate from college or from higher education, and they don't feel like they can really make a difference. Employers don't feel like they make a difference. Our whole program is designed and built in such a way to try to close that gap, so that when you finish our program, you are as best as we can prepared to make you prepared to really have an impact in the workplace. We do this through ensuring experience and experiential learning, and what that means is that when you take classes and work with us, we try to use as much as possible real world examples and scenarios, so that while you don't necessarily have you know, professional experience, you do have something that mimics it as close as possible. And where that's not possible, the only other thing we can provide you that will give you that power of real work experience is to share with you the experience and perspective of folks that have been working in the field. And so another way that we bring that to our program is sort of, I alluded to it earlier, is that our faculty are not just academics. They're not just folks that train and then go on and do research, but folks from lots of different walks of life, and many of them with both academic and professional experience and you know, elements of their career. And because data analytics is such a broad field, we have to represent those lots of different areas. So we have statisticians, as you would imagine, and computer scientists. We also have engineers and folks that work in cognitive psychology. We have faculty that have a background in business and industry, and even natural scientists like myself. I hail from the biological sciences. So all these elements are created to provide you or you know, prospective students with the richest experience to make you as informed, effective, and influential in this new profession as possible. So to kind of build on that a little bit, I have two examples here of slides that I use sometimes when I go talk to folks about what it is that we really think is important as a group of individuals, as someone that runs a program like this. I come and I give talks like this a lot, with the focus is to try to talk about what is important, because if we're training students, we have to have an eye on what's going to be important, not just today, but into the future. And that helps us build a program that services students, again, not just today, but throughout their career. So just recently, well, now I guess time's flying because of COVID, but just a year or so ago, I was invited to go give a talk for folks at the United States Army Network and Enterprise Technology Command about what the future challenges and benefits of data analytics will be. And that's something I'm sure many of you are also thinking as you consider pursuing, a degree in this area. So a couple of things that I gave them advice to, and I want to mention them here because I think it goes to why we built the program the way we do and the things that we think are important, is that I think if you look at the future of analytics, it's going to focus on people. So many of our students are very afraid that Google will create a tool that will make analytics and data science, not valuable anymore. And I can tell you that both as an educator and as someone that works actively in industry, the technology is an important part, and it's an important part of what we do to train you. But the most important part is you as analysts and the way you think about questions. So sense making, considering the analytical process, and I'll show you a visual in a few minutes that kind of shows you a little bit more specifically about what that means. Also is the idea of embracing new data streams. One of the things we do as a program is not just train you in those fundamentals, okay, but also allow and build a program that gives you exposure to lots of different types of data. One classic example is the spatial example that we just went through with Dr. Sarvis. We've had a spatial analytics class for a few semesters that looks at the underlying analytical components of dealing with spatial data. Now, Dr. Sarvis is going to come in and bring us an even richer perspective on how that data is collected and how it can be used through other sets of tools. So together, we offer you several classes built around the challenge of spatial analytics. And spatial analytics, as Albert alluded to, is a really important component of the types of data, especially with wearables, IoT, and so many other emerging sets of technology and sensors. The other one is modeling innovations. Modeling innovations covers a very broad set of challenges. And one of the classes or the focus of our program that sort of leads to that and helps train students to think innovatively about modeling and about creating computational or mathematical representations of real world things is thinking with data, thinking computationally, both of which are really, strong, important elements of any training in analytics. And then of course, statistical and machine learning. And we've got a great sequence of courses that Dr. Ruzba Sadegian actually has built for the most part and leads that focus on things like machine learning, and it's really critical. And I think my mentioning this to NetCom is just a reinforcement of why those things are important. The other one is this kind of really interesting talk. It's a TED talk by this gentleman here, Stuart Firestein, and he wrote a book called Ignorance. And it's interesting, but students are often confused and about what is important, as training for analytics. And one of the things that we do is how to ask good questions. In industry, and as I wear my other hat at Wild Fig, I share a lot of times my experiences with my students, and probably the most frequent thing that I'm brought in as a as a consultant to do in industry is to help big organizations, small organizations think about their data quantitatively. They have business questions, right? And they know there's things that they don't know. And they know there's things that by using analytics and mining their data and leveraging their data as a resource, that could bring lots of information that would help them run more efficiently, more competitively in industry. And Stuart Firestein, who's the gentleman in this top picture, he wrote this book called Ignorance and gives this great talk about how so many students think that science is about things that we know. In reality, the most important thing is what we don't know. And one of the things, I feel like we really push to train students is how to ask the right questions and how to use data then to address those questions. And it's incredibly important. And so those two elements, I think, continue to point to the fact that strong analysts are going to be the guiding sort of factor in data analytics moving forward, and not just, for the next couple of years, but for decades. AI, machine learning, these things are progressing incredibly well, and they're all great tools. But at the end of the day, analysts that are trained to understand both how to think with data and then how to execute that analysis are going to be critical. And our program is built to do that. So reinforcing this idea of how to train analysts and how to be how to learn data analytics. A quick, visual here is just the analytics life cycle, if you will. This is the sort of steps in very general, sort of buckets about how you tackle an analytics problem. Okay. And the specifics of these steps aren't really important. What's important is that, there's a number of areas where the influence of training in analytics is so critical. And where we spend time training folks to make a difference is really important. And so I think it's worth talking about critically, or for a moment, the critical touch points are places like questions. Asking the right questions can dramatically increase the success of an analytics endeavor, both in industry, government, anywhere. Exploratory data analysis, understanding the data through visualization and through examination is a critical component to success. And again, this is an area where we train students to think about. Analysis is another critical touch point in the analytics process. Actually executing the analysis, making sure that it's the best, most sound analysis to address the questions and to leverage both the data that's available and the quality of data you have. All those elements are critical. And again, this is something that's a real centerpiece of the training program that we have in the graduate analytics programs. Validation is another area, and that's really wrapped up in the idea of producing, great analytical work. And then finally, step 8 is communication. And we have a number of classes, almost all of our classes focus on at some level at the experience of both conducting and communicating analysis. But we have specific classes around data visualization and then actually a capstone sequence. And I'll show you a little bit more about our program. But the key component is the fact that, these are strong, important touch points in the analytical process. And each one of those that's vital is a centerpiece or at least a key element of the training that we do. And again, here, to expand this, oftentimes this is where folks point to this idea of, intelligent applications and AI. And again, even if you excuse for a moment the idea that, exploratory data analysis can be automated, which we're getting better at, but I don't think it's at a place where we would abandon it. And validation and communication can be automated. There's still the point of questions and analysis, which are the centerpieces of our program, and they're so important, to successful analytical endeavors. So again, just sort of looking broadly at the field of analytics, about where it's going in its future, and how it links up with the way that we think about and approach training in analytics. So let's talk a little bit more specifically about what a master's degree or a PA, this is specifically looking at the master's degree in data analytics looks like. To my knowledge, the program, that will be established in the fall at HU LATAM will mirror this structure, if not in execution, definitely in composition. So it's about 36 hours of education. 15 to 18 credits of them are what we call core credits, and those are courses that train you to have all those fundamentals that I was just talking about, all those things, and we work diligently as a faculty to make sure that keeps pace with what analytics and data science looks like in the wild. And so that the core training really gives you that solid foundation of statistical thinking, computational thinking, how to think about things scientifically with logic and reason, and really that even that communication component too, and the exploratory data analysis. So all those elements are there. The balance of your time in the graduate program are elective credits that you get to choose, and you get to kind of dictate where your expertise will go. And we do this for a number of reasons. One, because we want students to find something that matches where they want to go or where they are, most effectively. And you've already heard about some of the elective credits, things like spatial analysis, and we do have some domain specific focus. We have a healthcare informatics, set of courses, and we have collaborations with other programs. We also have very specific areas, like I mentioned before, machine learning, natural language processing. We have courses really focused on predictive modeling or forecasting. All those elements allow you to sort of craft your own, your own program to some degree, sitting on that foundation that best sort of suits where you want to go with your career. The final element of our training is 6 credit hours, 2 courses, in experiential credits. And what this is a capstone experience. Again, going back to our original mission, the key here is to try to create a scenario under which, now that you've learned and worked with these things through a series of courses, you get to apply them all to a real world, mission. And that can be of your design, or can be through collaboration with faculty or through outside groups. And I'm going to mention in a few minutes about some of those collaborations and our continual effort to bring some of those real world experiences into the classroom. So to sort of wrap up a little bit, and I'm going to talk for a few more minutes about what some of those practical experiences do, or look like, I'm sorry. So as a student, at HU, working on your graduate work, there's lots of different ways that you can get experience. Like I said, almost every class tries to use real data. Our faculty constantly try to bring in new and interesting data sets so that you get some sense of what things look like in the wild. But also, it's about questions. It's about getting that experience working with other groups that have those questions and helping them craft how those questions go from a very domain focused, inquiry into something that's very data focused. And this is a plethora of some of the folks that we work with. And so let me start with the top right here, Pennsylvania Department of Health. The Pennsylvania Department of Health is actually a collaboration that I'm working with now, and we're going to have several grad students involved in that project, and it's actually related to COVID. We secured a grant to do wastewater epidemiology, which is basically taking wastewater and using genetic methods to test that. Now, the genetic work is actually fairly, off the shelf. We get water samples. We work with local wastewater treatment facilities, and they sample the water, test, put the water into genetic test kits, and send that off to a lab. We get the data back, and that's where our students get involved. The question is really trying to understand, what is the spread of COVID? How does it spread across the area of the city or of the region? And how can we predict and forecast where it's going? And so, taking those point measurements of how much virus is in the wastewater, i.e., how it's distributed and how people are passing it from themselves into the wastewater treatment facility, in the city, and then trying to analytically look at both estimating what that looks like through several point measurements and where it's going based on historical trends and dynamics. And we've partnered with the state epidemiologist. They're going to be working directly with our students. We've got, like I said, a nice large collaboration for our students. It's a great experience to see what it's like to work with teams, what it's like work with very cutting edge methodologies and new data streams, like I mentioned earlier, and also what it's like to tackle these things in a real world scenario where things are changing all the time. The second one in the middle there is Pennsylvania Liquor Control Board. In the United States and in several states, the control of the sales of liquor is, highly regulated, and in Pennsylvania, that's the case. The Pennsylvania Liquor Control Board is a government, group whose job it is to mandate, to manage, and to regulate the sale of alcoholic drinks and beverages. They actually came to us, to our department, and said that they had very large sets of data and wanted help working with them. They didn't have a big research budget, so they weren't going to partner with one faculty member or another on a specific grant kind of project, but they wanted to work with the data. They had lots of questions, and they wanted help. So we actually partnered with them and created a program where our capstone experience, the last 2 semesters of one of our graduate cohorts, was dedicated to the Pennsylvania Liquor Control Board data and their questions. A group of students applied and were accepted into this cohort. They were brought in, they were trained by the members of the PLCB, which is the Pennsylvania Liquor Control Board, about the data, about the questions and the challenges that they had. Those folks then made some of those questions their capstone project, and actually use that as their centerpiece for their before graduation for their experiential learning component. And so that kind of partnership, that kind of collaboration between in this case a regional government group and a real world data question is a great opportunity for students to build experience. Okay, in the bottom corner, is SRBC. This is the Susquehanna River Basin Commission. This is another group that the university partners with. The SRBC actually manages the rights and the stewardship of the river, the Susquehanna River, which is in its entire ecological basin. This is a huge footprint that covers our entire region and goes down into a large estuary called the Chesapeake Bay that goes into the ocean, which is on the eastern coast of the United States. It's a large series of water, covers 3 states and actually more like 4 if you broaden out the area. So it's a huge area. They have lots of data, a lot of passive sensors. I started this as a class with doctoral students. 5 doctoral students started this collaboration, worked for about a year on anomaly detection. They brought in all this data. They had so much passive data, and they really needed a way to sort of automatically identify where there were problems or opportunities. And so the graduate students led the research, supported by me, but really independently led the research, identified the opportunities, identified the best analytical process to seek out those anomalies, and then actually built a software application, a dashboarding process system by which the data would flow into the application, run the analysis, and then feed back that insight through visualization to the stakeholders at SRBC. It's a great collaboration, and it actually yielded further projects. I now have an additional 2 graduate students working on similar but more complicated problems. Again, doctoral students. Really great opportunity. A few more, and I don't want to go over my time, so I'm going to wrap it up really quick. But the University of Maryland School of Medicine has established a very strong partnership with our doctoral program, such that they needed analytical expertise, and our graduate students are now tackling some very interesting and emerging problems in the biomedical space that are heavily data driven. Additionally, the Allen Institute for Brain Science is working with some of our most recent doctoral students on, that we actually founded postdoctoral positions, and they're doing genomics data. So again, I want to bring this in for landing, so out of respect for everybody's time, but this is just a handful of examples of the kinds of hands-on experience that you can develop, and we actively work to develop for our graduate students, both master's and doctoral students. And it's the kind of thing that makes your education and your training as robust as possible, and really helps to prepare you to move out, into a career in the analytical sciences. Again, I think our vision, for HU LATAM is to create regional relationships with similar organizations, in the South American, or in Latin American region, that will allow us to even make these things a little bit more regional, a little bit more relevant. So with that, I'll kind of cut things off and open up for questions, if that's okay.
Thank you. That was very interesting. Any questions? If you have any questions, you can type it in the chat box. You can activate the chat box from the top bar. You see a bar top there. There's one of the options is show conversation. If you click on it, you are able to type your questions. I don't see any question coming while people are probably thinking about their questions. Let me quickly ask a question from the point of view of somebody who has been both in business side and academia. The younger generation, one thing that they are worried about is the job market. They want to know after their graduation what would happen. Is there a good job market for their major? What's going on? I think you are the best person that can answer to this question. So please share it with us.
Yeah, well, it's an interesting point. So, about 2 years ago, a really interesting study was done looking at the job market in data science and analytics, and found that the average applicant was on the job market for 3 weeks, which in retrospect is actually, for a career path that pays large salaries, is actually really fast. And everything I know is that the job market is equally, good, if not better now, post-COVID. While COVID has created enormous challenges, for the world and for people, ironically, it has created an enormous opportunity for analytics. Any organizations you talk to, and I say this both as sort of the head of an academic program and also as someone that runs a business. All organizations, big, small, government, non-government, in industry, are looking for ways to be more efficient and more effective with limited resources. And this is a place where analytics is incredibly powerful, whether it's through automation, whether through the identification of opportunity, or just through efficient, the efficient optimization of any process, really, but oftentimes those in industry. Analytics is a key component to that. And so the value and the opportunity of analytics is growing. I know that almost any analytical business or group that I'm working with is very busy, and I think it's reflected in the marketplace. So I think the prospects for data science and analytics professionally is as strong as it's ever been, and probably poised to grow given the way that things look, on the economic horizon.
Thank you. Fantastic. That was a complete, answer to relieve people. So thank you again. Thank again our wonderful speakers. They did a great job. You have seen it. And thank you, the attendees, for attending these sessions. If you want to know more about our program, the Data Science and Data Analytics program, please follow the link that I have shared on chat. You can find more information over there. Also, this is the last session of weekly webinars. If you want to watch the former webinars, feel free to go to Harrisburg University YouTube channel, and I can just copy it here too. So you can follow this link, go to YouTube channel of Harrisburg University to see the previous sessions. Thank you again, everyone, and have a good day.